Good morning, everyone. My name is Rishabh and I'm from branch CSC AIML. I'm going to talk on the topic the role of IEEE in quantum computing. Introduction. Quantum computing, a rapidly evolving field with transformative potential. IEEE, global leader in technology standards, research, and professional communities. This presentation explores IEEE's unique contribution to quantum computing and advancement. What is quantum computing? Quantum computing is an advanced field of computing that leverages the principle of quantum mechanics such that superposition and entanglement to process information in fundamentally new ways, solving certain complex problems much faster than traditional classical computers. Key concepts. Qubit, a basic unit of information in a quantum computing. Unlike a classical bit, which can only be 0 or 1, a qubit can be in a state that is a combination of both 0 and 1 at the same time, a phenomenon known as superposition. What is superposition? Enables a qubit to represent a multiple process simultaneously, allowing quantum computer to process vast number of possibilities in parallel. IEEE's mission in quantum technology. IEEE's mission in quantum technology centers on advancing research, development, and practical application of a quantum science for benefits of humanity and professional communities worldwide. IEEE aims to facilitate interdisciplinary collaboration across academia, industries, and government to drive innovation in quantum computing, quantum information, quantum engineering, algorithms, and related technologies. The organization prioritizes fostering global awareness of quantum advancement and their practical impact on areas such as health, industries, infrastructure, artificial intelligence, and clean energy. IEEE standards for quantum computing. IEEE has established several key standards for quantum computing to address terminology, architecture, algorithm design, performance, metrics, and security. These standards provide an unified framework to support interoperability, industrial collaboration, and innovation in quantum technology. IEEE P7130 Standard for Quantum Computing Definition establishes a common nomenclature for quantum computing defining essential terms related to quantum principles such as superposition, entanglement, tunneling, and more. IEEE P3120 Quantum Computing Architecture defines technical architecture for quantum computer and specifies requirement based on technology type and supported qubit modalities. IEEE P2995 Quantum Algorithm Design and Development provide standardized methodologies for creating a document quantum algorithm facilitating consistency in quantum programming and research. Key Quantum Computing Standards Initiative. Several key initiatives drive the development of quantum computing standards, usually coordinated by IEEE and collaborating international organizations. These initiatives address foundational terminology, algorithm development practice, performance benchmarking, hardware architecture, and cryptographic protocols. IEEE Quantum Initiatives launched in 2019, this is IEEE's effort usually for quantum technologies encompassing standards, development, research, education, and industrial engagement. IEEE P7130 Standard for Quantum Computing Definitions. This project creates standardized nomenclature for quantum computing concepts such as qubits, entanglement, and superposition, reducing terminological confusion and enabling easier collaboration across disciplines. International collaboration and future direction. International collaboration and future direction with consortia such as Quantum Economic Development Consortium such as QEDC, Economic Development Consortium Joint Technical Communities and European Group to harmonize standard and accelerate adoption. And European groups to harmonize standard and accelerate adoption. IEEE Quantum Energy Initiative. IEEE Quantum Energy Initiative (QEI) represents a pioneering standardization effort focused on defining and improving energy efficiency matrices for quantum computing and quantum stimulation technologies. The main objective of IEEE Quantum Energy Initiative is to create universal matrices and methodologies for evaluating the energy efficiency of quantum computers, including gate-based quantum processor, quantum annealers, and quantum stimulators. QEI emphasizes both quantum level and end-user level definition of performance, applying its standard to all qubit technologies and encompassing both classical and quantum control chains. IEEE Quantum Technical Community. IEEE Quantum Technical Community (QTC) is a premier interdisciplinary group with IEEE dedicated to fostering the advancement, standardization, and application of quantum technology across research, industries, and education. The QTC unites researchers, engineers, academics, and industries professionals to address key challenges in quantum computing, quantum information, quantum engineering, algorithms, and related domains. QTC is deeply involved in organizing IEEE Quantum Week, which features conference, workshops, and technical paper sessions for quantum computing and engineering. Conference and publication. IEEE Quantum Week, International Conference on Quantum Computing and Engineering (QCE). Record attendance, keynotes, workshop, career fairs, and student mentoring. Publishes leading journals like IEEE Journal of Quantum Electronics. Benchmarking and metrics. Develop benchmarks for quantum computational evaluation. Provides practical metrics for academy and industries. Metrics make it possible to gauge, process, identify bottlenecks, and guide development priorities in both research and industrial developments of quantum computing. Benchmarking establishes consistent method for assessing the performance of quantum processor, software, and end-user application. This promotes reproducibility and fair comparison among quantum platforms. Educational and workforce development. IEEE Quantum Week and related conference regularly features dedicated tutorials, workshops, and technical paper tracks focus on quantum education and skill training for aspiring quantum engineers and scientists. Special issues and publications such as IEEE Rita and Transaction on Quantum Engineer highlight innovative educational programs and methodologies for teaching quantum information science and engineering. IEEE partners with government, academia, and private industry to address national and international quantum workforce needs, including K-12 lessons, planning, university level courses, and professional development modules. Workforce building tutorials, student challenge, and hands-on hackathons are organized as part of major IEEE events, allowing participants to explore quantum coding, device operation, and real-world application with guidance of an expert. IEEE Global Engagement collaborates with government, industries, academy, international conference, and outreach initiative, supports global standardization and technological adoption. IEEE initiatives ensures that quantum research and innovations are accessible, globally competitive, and aligned with societal needs, accelerating quantum technology adoption on a worldwide scale. IEEE global engagement creates new platform for cross-border collaboration, inspired robust marketing development. Future direction and challenges of quantum computing, scalability and error correction. Expanding quantum processor from 10 to 1000 or millions of qubits involves overcoming several scalability and fidelity hurdles, including quantum error correction and noise suppression. which are technically and physically demanding. Verification and validation. Reliable and automated methods for testing, benchmarking, and verifying quantum devices and software are urgently needed. IEEE targets this through benchmarking standards and quantum software engineering efforts. IEEE supports coordinated roadmaps to guide research, priorities, and connect industrial needs to technology development, working with national labs, international organizations, and government partners to address pressing technical gaps. Formalizing practice for software engineers and requirements gathering for quantum system, as well as facilitating open data sharings, are new direction informed by the lessons from the classical computing and large-scale science projects. Conclusion: IEEE plays a vital role in progress of quantum computing, leads in standards, community building, conference, and education, critically in shaping the future of quantum technology globally. Thank you.